The topic of this video is determining the present or future value of a lump sum of money. This is a continuation of the previous video. Alright, in our previous video, we solved a problem where Tanisha was investing $1,000 in an account, and that account was compounded quarterly. We found that it was going to take 8.82 years for her to turn her $1,000 into $1,550. But the second part of that problem asked, what if we changed it from quarterly to continuously? Then how long would it be before she gets the increased value? Then how long would it be before the 1,000 turns into 1,550? All right, so let's go ahead and solve this problem. Continuously means we're dealing with a different formula. When you see that a count is compounded continuously, we're using the PERT formula. F equals PE to the RT power. Just like before, we're going to read the problem, and as we identify the value of our variables, we'll write them down. Let's begin. Tanisha has $1,000. That's P, the amount she has right now in the present. To invest at 5% per annum, that's R, the interest rate, 5%, which is the same thing as 5 times 0.01, which is 0.05. Compounded continuously tells me which formula to use. Notice there is no N in the formula. How long will it be? Tells me that T is my unknown, and I'll leave T in my equation, before she has $1,550, which is the amount of money she will have in the future. That's telling me F. Okay, now we plug in. So we get 1,550 equals 1,000 times e to the 0.05t power. All right, the variable I want to solve for is t, and it is up in the exponent, so I want to use my converter. But my converter only has a place for three things: one base, one exponent, one argument. In our problem, the base is e, not 1000e. If I wanted the base to be 1000e, then both the 1000 and the e would have to be in parentheses. Since there are no parentheses, the base is just e, which means e is the base, 0.05t is the exponent, 1,550 is the argument. This 1,000 is extra. We're not allowed to have any extra, so we have to find a way to get rid of the 1,000, so we divide by 1,000 on both sides. This gives us the statement 1.55 equals e raised to the 0.05t power. And now we have three things, so we can put them in our converter. The base is e, so it goes in the blue box. The exponent is 0.05t, so it goes in the exponent position. And 1.55 is the argument, so it goes in the red circle. All right, now matching up the colors and shapes, on the other side we would get log base e of 1.55 equals 0.05t. We've now rewritten our exponential statement in logarithmic form, and this helps us to solve for the value of the variable. All right, so here's what we now know. We now know that 0.05t is equal to log base e of 1.55. Now log base e is a natural log, so I could rewrite this as the natural log of 1.55. And since I want to know what t equals, I note that the t is being multiplied by a 0.05. So if I were to divide by 0.05 on both sides, then that will tell me the exact value of t. T is exactly equal to the natural log of 1.55 all divided by 0.05. Now I'm ready for a decimal approximation. And this time I'm in luck. I don't need the change of base formula because natural log is one of the buttons on my calculator. So I hit natural log of 1.55, close parentheses, enter, then divide 0.05, enter, and I get the value 8.77 years. This is the end of this problem, but it allows us to now make a comparison. Notice that when the account was compounded quarterly, the amount of time that it took for Tanisha to turn $1,000 into $1,550 was 8.82 years. when we changed it to continuously, the time went down, but not by very much, 8.77 years. Let's just do a quick mental math here. 8.82 minus 8.77. What's the difference? Subtracting that, that's 0.05, which is the fraction 1/20th. There are 365 days in a year, but if we call that 360, as many banks do, and then we divide that by 20, we get 18 days. The difference between this and this is 18 days. Not a huge amount of time when you've waited for nearly 9 years. So we learn from this that the way your account is compounded does not have a tremendous impact on your investment. But what does have a tremendous impact on your investment is the interest rate. So whenever you have two accounts, you always want to make sure that you look at that interest rate, because 9 times out of 10, that is going to be the most important determiner in deciding which one of your two investment opportunities is the best opportunity. And if you're ever still unsure, then feel free to do this kind of math and compare investment opportunities to find the one that will give you the most money.